Hey everybody, this video is example 1 in section 4. Section 4 is rational inequalities. I just finished recording a few examples for section 3, which is polynomial inequalities. We are going to be going over our super efficient and accurate and reliable and helpful method for determining when a rational function, equation, expression is going to give you output values that are either greater than 0, less than 0, greater than or equal to 0, less than or equal to 0. So let's get into it. I want to preface this by saying if you think you need a little bit of practice with graphing rational functions in general, I do have a video which is called something like the absolute best way to graph rational functions, the strategy method something. So I would go and watch that video. There's just one video going through exactly how we find all of the key components, and then there's a bunch of examples of how we basically take the information, put it together to get the graph. But we're going to be doing a little light graphing for this. It's a bit of a sketching, and let's go. So as a mini recap, very mini, how do we find our x-intercepts? We find x-intercepts by setting the numerator equal to 0, but you're going to treat it like the way I just went over in the last section, section 3. Treat it like how we graph polynomials. You're going to factor it. You're going to get your x-intercepts. You're going to think about your end behavior, your local behavior, yada yada. Okay? How do we get vertical asymptotes? Well, those are interruptions to our domain, and therefore we want to figure out when the denominator would equal 0. We're going to pay attention to the multiplicity on this too to figure out the asymptotic behavior. So AB stands for asymptotic behavior. If it's even, it means that both branches are facing the same way against the asymptote, either both down or both up. And if it's an odd multiplicity on the factor that we got the asymptote from, then it's that's not what I wanted. Then it's odd asymptotic behavior, so their branches will point in opposite directions, either up on the left, down on the right, or vice versa. All right. After x-intercepts and vertical asymptotes, I'm just going to go up here. What about our y-intercept? We plug in 0 for x and we evaluate. It also really comes down to being your constant over your constant, but we'll cross that bridge again in a moment. And lastly, I almost refuse to call it a horizontal asymptote because it's the dumbest thing to call it. It's very misleading, confusing for students. I'm calling it end behavior because it is what it is. How does the graph behave on the ends, the far left, the far right? We analyze leading term over leading term. So the term with the biggest power on top and on bottom, just those, reduce it as far as we can. Then I'm going to erase this in a moment. So if you need to copy it, copy it. You're basically going to be looking at something ax to the m over bx to the n. It's possible your a's, b's, m's, n's are 1, right? Anything's possible. So there's 3 scenarios. If m is less than n, then your end behavior will happen at y equals 0. If m is equal to n, and I elaborate on all of this in those other videos, so please watch that if you want to understand why. I'm just getting to the nitty gritty. Your end behavior is going to be at a over b, and if m is greater than n, then you have what we call an oblique asymptote. So it's basically a polynomial of some sort. Perhaps you have a linear, perhaps you have a quadratic, cubic, whatever. And the way you get the equation of that oblique asymptote is you do long division and you drop off the remainder, and the rest of your quotient, ignoring the remainder, is the equation of your end behavior, which you can draw dashed and help you guide your graphing journey. All right, I'm erasing all of this, so if you need to write any of this down or want to go look it up in the other video, just come back to this when you are ready to go. So similar to the polynomial section, we're going to figure out when this is greater than 0 by basically sketching a light graph of this. So if I kind of go ahead and get started, my x-intercept, I will only have 1 since the numerator is linear. Basically, I'm going to erase a lot of the work, okay? I'm setting 3x plus 3 equal to 0. That means 3x equals negative 3. So that means x equals negative, sorry, it's sloppy, x equals negative 1. So my x-intercept as an ordered pair, because we love an ordered pair whenever we can, is negative 1 comma 0. And since this is invisible parentheses to the first power, my local behavior is linear. So it will behave like a linear at that x-intercept. Next up, mark that there. Next up, my vertical asymptote, like I mentioned before, comes from our denominator. So really, again, I'll erase this all in a moment. I'm going to set that equal to 0 because I want to know, well, what makes the bottom undefined? So I know where to put my caution tape. 2x is -4, so x is -2. Here it's not in ordered pair because it's an asymptote, and an asymptote is a graph, essentially. It's a dotted graph. So I'm going to leave it x equals -2. And for my asymptotic behavior, since this is to the first power, that tells me my asymptotic behavior is opposite for the odd power of 1 that the multiplicity was on the factor that my asymptote came from. If you have more than one asymptote, each one has its own asymptotic behavior. Next, from here, again, all of this is very quick if someone's not blabbing to the entire time, so sorry. Y-intercept, I'm going to fill in 0 for x, and basically that ends up leaving me with 3/4. It's good to consider what 3/4 is as a decimal so that you can kind of, I'm just going to squeeze this in a little bit better, so that you can figure out like what things are above or below it, like is your end behavior higher or lower than your y-intercept, all that good stuff. So that's 0.75. And last, my end behavior. Is it going to be a horizontal asymptote? We shall see. So if I do leading term over leading term, I'm looking at 3x over 2x. And if I want to analyze this all the way at the infinities, positive and negative, the x over x is meaningless. Infinity over infinity, essentially it's 1, right? So what's left behind is just the 3 over 2. That right there is my end behavior. So if my end behavior satisfies the equation of y equals 3 over 2, then it is indeed a horizontal asymptote, since that is a horizontal line. 3 over 2 is 1.5, so it's going to be higher than 3/4. All of this is going to be handy dandy information for us along the way. Also, please note, a horizontal asymptote, or your end behavior, you can cross. It is not like a vertical asymptote, okay? You're welcome. Now, I'm going to sketch the graph, and after that, I'm going to answer the inequality question. So what am I looking at? Let's see, -1 and -2. And actually, let me space this a little bit better. I'm going to focus more on the upper left area, you know? 1, 2, 1, 2. So what am I looking at? This is 3/4, and this is 3/2, -1 and -2. So my x-intercept -1, and it's linear. Make a little note for myself. Then my vertical asymptote is at -2. Can we see that okay? Just want to make sure I'm on the screen all right for you guys. Okay, so that's better. Okay, then my y stuff, let's see, and behavior. And y-intercept. All right, so if I'm going to go ahead and draw, so I'm just moving up, I'm cutting off a little bit of the problem here, but the graph, you know, that I'm analyzing is on the screen. So over here, I'm going to focus on actually drawing the graph in red. These 2 points are going to have to connect. They're really 2 points on my graph. My end behavior is quite literally telling me how my graph behaves towards the far left and far right. So I have to approach that. This is a linear intercept, so when I zoom in, it's going to cut through pretty flat. Then over here, it's going to curve around and approach my vertical asymptote as best as it can. Now my asymptotic behavior, we said, was going to be opposite. So that means if the red branch is pointing down on the right side, then it's going to be pointing up on the left side. So it's going to be pointing up on the left side right there, and then on this side it's going to keep getting closer and closer and closer to the end behavior. I also know it can't be over here because I don't have an x-intercept, so that wouldn't make sense, blah blah. Go watch the video if you need help with knowing how to graph. Now this is greater than 0, And like I said, you should be pretty quick at this. I want it when it's above the x-axis. So the parts I'm looking at are going to be the parts I'm just going over in yellow. So what will be the final answer, right? So from left to right, it's greater than 0 when we are looking at negative infinity until -2. That's an asymptote, so it always gets a parenthesis. Union, and we're starting at 0, at the y value of 0, which is -1. It's not or equal to, it's just greater than, so I'm just going to do a parenthesis again, -1 until infinity. And there you go. I hope you feel like a genius. If you follow and you're going to watch another video to make sure you're doing a good job, then go ahead and give the video a thumbs up. If not, you can go ahead and give it a thumbs down. Questions, comments, concerns, requests, whatever you need, put it in the comment section. Check the description box below for the links to the videos all on this topic organized in a list, or you could go and check the playlist and kind of analyze by thumbnail. I try to make the thumbnails quite clear to let you know exactly what is in that video. That's it for now. Adios.